Many of you have been shown fractions represented by circles, squares, and sometimes even lines. There's some fallacy associated with using the circle, for example, that you get into trouble with when you get into dividing these circles up into even smaller and smaller segments. This particular circle has been divided into 3 segments. This square has been divided into 3 segments as well. So, for example, this shaded region would represent 1/3 of the circle, and this shaded segment would represent 1/3 of the square. Now the trouble comes in when you divide this circle up into smaller parts, even smaller parts. It becomes difficult to manage. When you use the square, it's a little bit more manageable. But I want to teach you a method that is superior to both of these, and it actually helps you to understand what a fraction is. The definition of a fraction is it actually is a number on the number line, and I want you to see that. For example, we have here what we call a unit segment, okay? And we're going to denote this unit segment by starting at this leftmost point, considering that point to be 0. And then the rightmost point, considering this to be 1. Now, if we take this segment, unit segment, and divide that into 3 equal segments, like this, we have 1, 2, 3 equal segments that are the same length. So I can represent, starting at this point, 0 over 3. This point would be 1 over 3, 2 over 3, and 3 over 3. Okay? So on this line, number line, we see that the distance from here to here is 1/3, from here to here is 1/3, and from here to here is 1/3. Here's an example where we have taken 2 unit segments of length 1, and we have divided the first one into short segments of thirds. That means that this segment from here to here is exactly 1/3. The segment from here to here is exactly 1/3, and the segment from here to here is exactly 1/3. Each one of these segments is the exact same length. The distance from 0 to this first point, which we are calling 1/3, is equal in distance from the point that we're calling 1/3 to the point we're calling 2/3. Okay? Likewise, on our second segment, the second unit segment is divided into short segments of sixths. And so, for example, from 0 to this point that we're calling 1/6, the distance or the length is 1/6. So this represents 1/6 of the whole, which we're taking to be the segment 0 to 1. Okay? Now, what you'll notice is that if we want to identify a particular point, say if we want to know what 2/3 of the unit 0 to 1 is, we simply start here, which we're calling 0, and we'll count 2. So hence this is 1, 2. Thus we get 2/3. For example, another example, if we wanted to find 4/6, then we would start here and we would count from 0 to the right 4 segments, so 4 short segments. So 1, 2, 3, 4. Thus we would have our segment 4/6.